Welcome to Lesson 8.2, Understanding Software Development Approaches, Models, and Tools. In your Candidate Information Bulletin, we are in the Software Development Security domain. We are in Key Area of Knowledge A, which is Understand and Apply Security in the Software Development Lifecycle. Our topics are going to include Software Development Maturity Models, Integrated Product and Process Development, the DevOps method, Development project models, including Waterfall, V-Model, Spiral, RAD, and Agile, case tools, and software development testing. So the Software Engineering Institute, SEI, at Carnegie Mellon University developed an evaluation model intended to improve the process of software development. The model identifies 5 major levels of maturity with the intent of helping organizations recognize their level and progressively improve. So we're going to look through the 5 different maturity levels. Now, each one of these levels would be applied to an organization at a specific point in time. And the reason to use a maturity model is to be able to identify the organizational maturity in a particular process, in this case for software development, but these models can actually be used for a number of different processes. But you want to use these to say, here's the level I am, and that's going to allow you to identify a level you want to move to and create a roadmap for moving to that maturity level. So in the first level, which is known as initial, the process is unpredictable, it's poorly controlled, and it's reactive. So that's just the initial or the lowest maturity level. The next level is known as managed. And in a managed maturity level, we have a project-oriented management, but it's still pretty reactive. Defined says project-oriented. And remember that this was really designed for software development, so it's project-oriented. There's basic standardization, and we are fairly proactive. When we get into quantitatively managed, the processes are measured and they're controlled. And then once we get into the optimizing maturity, we're focused on process improvement. So all the way down here at the beginning, where we're saying it's unpredictable, it's poorly controlled, it's reactive, to when we get to the top of the maturity model that says we're going to focus on process improvement. So in integrated product and process development, IPPD was developed by the Department of Defense and is described as a multidisciplinary management technique that uses design tools such as modeling and simulation, teams, and best commercial practices to develop products and their related processes concurrently. So as we're moving up that maturity model and we get to this optimized area, that's when we start developing processes like the integrated product and process development. The core of the IPPD process are integrated product teams. Integrated product teams, IPTS, are composed of representatives from all functional disciplines who work together to build successful programs and enable decision makers to make the right decisions at the right time. DevOps is a software development method that builds on IPPD, coupled with an agile process, which we'll look at shortly, and stresses communication, collaboration, automation, cooperation between software developers and engineers, QA departments, information technology personnel, and business units. A DevOps approach aims to maximize efficiency, predictability, and security. A DevOps approach aims to minimize probability of failure, cost, and risk. So again, DevOps attempts to maximize efficiency, predictability, and security, where a DevOps approach attempts to minimize the probability of failure, cost, and risk. There are multiple project models that can be used for software development. Models can be sequential, iterative, incremental, or hybrid. And we're going to look at each one of these types of models shortly. A project plan may also call for the development of a prototype, sample of code for proof of concept purposes, and applications that are subject to a strict certification process may need to include a clean room approach. Now, a clean room approach is a structured and formal method of developing and statistical quality control with the goal of eliminating defects prior to release. So again, a clean room approach, a structured and formal method of development and of statistical quality control with the goal of eliminating defects prior to release. Sequential project models are linear. Sequential approaches are often referred to as single step, one step at a time. The waterfall model requires that each phase be completed before moving on to the next phase. The V model emphasizes verification and validation at each phase and testing to take place throughout the project. So in a waterfall model, we have to complete one phase totally before you move on to the next and the next. The V model is also a sequential approach, but it emphasizes that at each phase you need to stop and do verification, validation, and testing before you move on to the next phase. Iterative and incremental project models develop software using repeated cycles, which is our iteration, related to specific functionality, which is incremental. So think of it as developing code in chunks, and those chunks use repeated cycles, iteration, for each different type of increment. Iterative and incremental approaches are often referred to as evolutionary. A spiral model is an iterative approach that emphasizes risk analysis and user feedback per iteration. So we're working on small chunks at a time, and we're doing these repeated cycles until the development team has reached a point where they're satisfied with the output. Rapid application development, RAD, combines both prototyping, creating samples, and in iterative procedures. And then lastly, the Agile model uses iterative and incremental processes, so the repeated cycle related to specific functionality, but it emphasizes a team-based collaboration. Regardless of which model is employed, computer-aided software engineering tools known as CASE are going to be utilized. So computer-aided software engineering, CASE suites, include diagramming aids, a library of standard function source code, tools to define application programming interfaces or APIs, version control tools, code review tools, and project management tools. Regardless of model or approach, it's absolutely essential that software be tested. So as a security professional, it's critical that you know the different types of testing that can be applied during the software development process and even post-production and post-release. So we have 6 types of testing we're going to go through. We have unit, integration, validation, vulnerability, acceptance, and regression. For your examination, I want to make sure that you're familiar with all 6 of these. Unit testing is testing of small, discrete chunks of code. So not testing the full program, just we're taking chunks and we're testing those. Integration testing is testing multiple units of code to make sure that there's proper information flow between them and that that information flow is secure. Validation testing is testing to verify that the product meets the design specifications, and hopefully those design specifications include privacy and security requirements. Vulnerability testing is testing for security vulnerabilities. Acceptance testing is testing the end user performs to verify the functionality of the software and the acceptance of the product. And then regression testing is testing all major functions after an update or a patch is applied to verify that the changes didn't disrupt functionality, and should also be verifying that the changes did not introduce any security vulnerabilities. So unit testing, integration testing, validation testing, vulnerability testing, acceptance testing, and regression testing. That brings us to our Lesson 8.2 review. We started by talking about software development maturity models and their use, and we looked specifically at the CEI, CMM. We looked at the Integrated Product and Process Development, the IPPD, that was developed by the Department of Defense. We looked at the DevOps implementation of IPPD in combination with the Agile model. We discussed each of the types of project models, including Waterfall, V-model, Spiral, RAD, and Agile. We explored what a case tool is, and then we looked at the 6 different software development testing methodologies. So that brings us to lesson 8.2, Match the Meaning. We're going to go through 2 sets of meanings for this lesson. So in the first set, the terms I want to make sure that you're comfortable and familiar with and know how to apply are maturity model, DevOps, a prototype, Waterfall, Spiral, RAD, Agile, and IPTS. There's a lot of terms here. Take your time, go ahead and match them up. Put me on pause, and when you're ready, come on back and we'll go through these together. All right, let's look at our 8.1 terms, our first round. Maturity model. The objective is process improvement. DevOps builds on the IPPD, and it stresses communication and collaboration between teams. A prototype is a proof of concept sample. Waterfall was a single-step model. We have to finish one stage before we go to the next. A spiral was an iterative model with emphasis on doing risk analysis. RAD is iterative with prototyping. Agile used iterative, incremental, and it was very team-oriented. Remember that we combine Agile and IPPD, and that's how we get our DevOps. And IPTS were cross-functional teams. It's a lot here. You may want to go back to the lesson if this is an area that you're unfamiliar with. But before you do so, let's go into our second group of Match the Meaning. These are the 6 types of testing: unit testing, integration testing, validation testing, vulnerability testing, acceptance testing, and regression testing. So you want to match up the type of testing in the left-hand column with the descriptions in the right-hand column. So go ahead, put me on pause, match them up, come on back, and we'll go through them together. Welcome back to lesson 8.2 terms, second round. So we're going to start with unit testing. Unit testing is testing small, discrete chunks of code. Our integration testing is verifying the proper information flow. It's when we're working on multiple chunks of code and ensuring that the information is flowing securely and correctly between the code. Our validation testing is ensuring that the product meets the design specifications. Our vulnerability testing is testing for weakness and flaws. Acceptance testing is testing for functionality and end-user response and acceptance. And lastly, regression testing is post-update verification to ensure that any changes or updates did not impact the functionality or the security. So we're going to end this lesson with our CISSP exam tips. The first one is that the CMM model can be applied to any size or any type of organization, and I would suggest that it can be applied to almost any process. DevOps is based on the DoD IPPD technique coupled with an agile process. Regression testing should verify all major functions and ensure that new flaws were not introduced when there were any changes made or updates. So thanks for joining me for this lesson. I look forward to seeing you in the next.